Voyager 2 is different in becoming the first spaceship beyond the solar system. When he stopped the data transfer in November last year, this was curious at the mysterious boundaries of our solar system. Decades later, Voyager reached this mysterious border in a vast space and revealed the ripples through the scientific community. From mysterious signals to strange space forces, the results challenge our understanding of the last boundary of the universe. What do you do beyond this border? How can this reduce our perception of space? Prepare a trip to expand the boundaries of what we know about the space. Voyager NASA's mission captivated the imagination of scientists and lovers of the universe of the world, providing an unprecedented view of the solar system and other external boundaries. He continues to be surprised by revolutionary discoveries and data that crosses the interstellar space, and even NASA experts are noteworthy. From the detection of unexpected plasma waves to the identification of new information about space radiation, Voyager probe has surpassed expectations and has continued its mission for more than 40 years after historical launch. The Voyager mission, which began in 1977, includes two same spaceship Voyager 1 and Voyager 2, studying external planets of the solar system and ultimately moving to interstellar space. Designed for the magnificent tour of the external planet, the two probes went beyond the initial goals and went beyond the planned route. Voyager 1 has a difference in the fact that it is the farthest object of man on the Earth, and Voyager 2 was able to visit Chanwangseong and Negrimism along the unique path. Each spacecraft has 55 languages representing the life on life of Earth, and there is a gold record of 12-inch gold for laps that contain sound, images, and greetings. This record acts as a time capsule to provide ideas for culture and various lands. In 2012, Voyager 1 became the first spaceship in the interstellar space by striking NASA and the scientific community, and later by Voyager 2 in 2018. The two missions showed amazing changes in plasma density in Helios and emphasized the unexpected border of the border. After crossing the interstellar space, Voyager 1 observed the waves of mysterious plasma in the interstellar medium caused by solar activity. This wave critically understands the density and configuration of the environment. Another amazing discovery was to detect an unprecedented pressure on the edge of the solar system. This pressure may be associated with the interaction between galaxy spaceships, interstellar plasma, and magnetic fields, but the exact origin remains a mystery. This discovery emphasizes the complexity and turbulence of the most external boundary of the solar system. Currently, Voyager 1 and Voyager 2 have gone to the interstellar space outside the heliosphere, where the solar wind particles are no longer dominant. This boundary, called heliopoicity, indicates the point where the influence of the solar wind disappears, providing an increase in interstellar particles and space beams. Voyager 1 is currently 14 billion miles on the ground and Voyager 2 is about 12 billion miles. Despite the huge distance, the two spaceships continue to deliver the data to the Earth, but we reach more than 21 hours. Heliopause's detection was an innovative achievement, and Voyager's intersection provided the first direct measurement of interstellar space, providing valuable information on the contrast between the interstellar media and the sun bubbles surrounding the Sun. Voyager 1 and Voyager 2 have made numerous innovative and mysterious discoveries on the trip and have provided a deep understanding of unknown. Voyager 1 crossed the heliosphere border in 2012, and Voyager 2 had one of the most amazing results since 2018. This boundary means the transition from the field of solar energy to the interstellar environment. Researchers were surprised by the complex and dynamic characteristics of this area. The sailing found pressure on the border and implied the unprofitable force at work. This pressure may be the result of a hydrogen wall concentrated at a space ray or solar system that interacts with the magnetic field. The entry into the interstellar space shows that this boundary is not a fixed barrier, but a confused and changing area affected by solar activity. When Voyager 1 entered the interstellar space, he met unexpectedly low frequency fluctuations in the plasma as a result of interaction between space rays and interstellar plasma. When converting to audio, the waves make a terrible sound and provide valuable information about the density of interstellar space. Voyager data showed that the plasma density of this area was higher than lighting the structure and composition of the galaxy environment. Initially, scientists predicted that the Voyager would detect the aligned magnetic field with the galaxy magnetic field in the interstellar space. Instead, Voyager 1 found that the interstellar magnetic field was slightly tilted and was still influenced by the magnetic field of the Sun. This amazing slope includes complex interactions between heliosphere and surrounding interstellar media, which indicates that our solar system can be more crushed than spherical foam. When Voyager approached Heliopause, he found a space boundary, including an unusual mixture of sunny sunlight and galaxy spatial beams. In the framework of this area, Voyager shows the interaction between sunlight and galaxy by observing the rapid reduction of the sun particles with the growth of high-energy particles from interstellar space. The unknown layer before this showed that the protection of the sun suddenly stops, but gradually decreased instead of the formation of a dynamic and turbulent area where particles interact in difficult ways. When Voyager 2 ran through Saturn in 1981, he revolutionized an active intermittent stream in the ice moon. This intermittent stream produces water and organic molecules in space, suggesting that the underground sea is hidden under the Enceladus ice shell. This discovery has a significant result in astrobiology, increasing the possibility that the moon will include microbial life. Voyager 2 also delivers the detailed image of the Saturn rings to show the complex fabric and twisted patterns formed by the line and gravity interaction of the planet. Voyager 2, the only spacecraft visiting both Chang'e and Neptune, found the most unusual weather conditions in the solar system. One theory based on Voyager data suggests that methane can experience extreme pressure and temperature in the atmosphere of this ice giant, which can collapse and form diamonds and rise from inside. The exotic phenomenon of this diamond rain remains speculative, but this is one of the main explanations of the strange waiting behavior observed by the Voyager. During the flyby in 1989, Voyager 2 also found a huge storm system known as a big dark place. Like the magnificent red spots of Jupiter, this storm is the size of the Earth, exceeding 1,500 miles per hour. This is the most powerful when Liba registers in the solar system. Nevertheless, the big dark place was temporary, and it disappeared until Hubble observed Neptune, indicating that the Earth's atmosphere was fast and experiencing extreme weather changes. During the summer of Jupiter, Voyager observed a powerful horo for gas giants created by the interaction between Jupiter's magnetic field and the Moon's particles. He also captured the volcanic eruption in Io and pointed out the first direct monitoring of the active volcano in another world. The volcano of the Moon is promoted by the intense assistance of Jupiter, resulting in a heat of friction at the internal point. This discovery shows that the Moon can be more voltly activated than the planet by changing the understanding of the solar system's geological activities. In 1990, Voyager 1 captured his famous image Pale Blue Point and showed the Earth a small point in a vast space of 3.7 billion miles. According to the request of Carl Sagan, this cult photo emphasizes the vulnerability and meaninglessness of the Earth, strongly reminds us of our small places in a large universe. More recent, Voyager 1 has found Rumble's detection well in interstellar space. This low-frequency experience is a constant sound generated by the vibration of the plasma wave in the void outside the solar system. Unlike the short spikes of the plasma caused by sun flashes, this stable rumble reflects the environment of plasma beyond heliosphere. This thin music in the deep space has given scientists a unique way to measure the density of interstellar materials surrounding the solar system. The Voyager has not been developed to find the life of aliens, but collects valuable data for external environments outside the solar system, such as space beams, magnetic fields, and plasma. This information can provide ideas for conditions that can support alien biology if they exist. Voyager is not a direct search for life, but his data can help scientists to understand the environment where life can flourish in other star systems.